Hello everyone, today we embark on a journey to one of the most extraordinary and promising worlds in our entire solar system, Jupiter's icy moon, Europa, a small frozen orb that hides a universe-altering secret beneath its bright, smooth surface. Global, liquid water ocean, teeming with the potential for alien life. For hundreds of years, humans have gazed at the stars and wondered if we are alone. And right now, one of the best places to answer that question is not a distant exoplanet, light years away, but a moon, just 484 million miles from Earth, orbiting the largest planet in our solar system. Let us start at the beginning, when Galileo Galilei first pointed his telescope at Jupiter. In 1610, he discovered 4 large moons, now called the Galilean moons, and Europa was the smallest and brightest of them all. 4 centuries after, astronomers saw it as nothing more than a smooth, icy dot. But in the late 20th century, everything changed with the Voyager and Galileo spacecraft missions, which sent back data that would rewrite astronomy textbooks forever. First, let us paint a clear picture of Europa itself. This moon is only slightly smaller than Earth's moon, with a diameter of about 1,940 miles, and its surface is one of the smoothest in the solar system, covered in a layer of water ice that is almost entirely free of large craters. That lack of craters tells us something huge. Europa's surface is geologically young and active, constantly being resurfaced by water from below. The average temperature on Europa's surface is a brutal -170 degrees Celsius, cold enough to freeze rock solid. So, for decades, no one imagined liquid water could exist there. But then, scientists detected something bizarre. Jupiter's powerful magnetic field was being disrupted around Europa, as if a conductive fluid deep inside the moon was creating its own induced magnetic field. The only logical explanation? A global ocean of salty liquid water buried beneath the ice. This is not a small lake or an underground cave system. This is a world-spanning ocean that stretches across every inch of Europa, locked between a rocky seafloor and an icy shell, 15 to 25 miles thick. Now, let us talk about the scale of this ocean, because it will blow your mind. Europa's ocean is not shallow. It reaches depths of 60 to 150 miles, far deeper than Earth's deepest ocean trenches, which only go down about 7 miles. And even though Europa is much smaller than Earth, its ocean holds roughly twice as much liquid water as all of Earth's oceans combined. Think about that. A tiny moon has more water than our entire blue planet. The next big question is, how does this ocean stay liquid in such extreme cold? The answer is tidal heating, one of the most powerful forces in the outer solar system. Europa orbits Jupiter in an elliptical path, and as it moves closer and farther from the gas giant, Jupiter's immense gravity stretches and squeezes the moon like a stress ball. This constant flexing creates friction inside Europa, generating enough heat to keep the water liquid beneath the ice, even without sunlight. This is not a temporary heat source either. It has been active for more than 4 billion years, nearly the entire age of the solar system, giving life more than enough time to emerge and evolve. For life to exist, we need 3 key ingredients: liquid water, a source of energy, and the right chemical building blocks, and Europa checks every single box. We already have the liquid water, so let us move to energy. On Earth, almost all life relies on sunlight for photosynthesis, but Europa's ocean is completely cut off from the sun, buried under miles of ice. So, where would life get energy there? The answer lies at the bottom of the ocean, in hydrothermal vents, black, chimney-like structures that spew mineral-rich heated water from the seafloor, just like the vents that support entire ecosystems in Earth's deep dark oceans. On Earth, these vents are home to tube worms, blind shrimp, and bizarre microbes that use chemical energy instead of sunlight, a process called chemosynthesis. Scientists are nearly certain Europa has these vents too, because its seafloor is made of rocky silicate material, just like Earth's, and the tidal heating drives geological activity that fuels these vents. These vents release hydrogen, methane, and other compounds that act as food for microbial life, and that food chain could support larger, more complex organisms too. The third ingredient is the chemical building blocks of life: carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Europa has all of these. Water ice covers the surface, and comets and asteroids have delivered organic molecules to Europa for billions of years. Jupiter's intense radiation also breaks apart water molecules on the surface, creating oxygen and other reactive chemicals that seep down through cracks in the ice into the ocean below. Even the salt in the ocean comes from the rocky seafloor, as water interacts with rocks to release minerals that make the ocean salty and full of nutrients. So Europa is not just a wet moon, it is a chemically rich world with everything life needs to thrive. Now let us imagine what life might look like in Europa's dark abyss. It would not be life as we usually picture it. No plants, no animals that rely on sight, no creatures that need sunlight. Instead, life here would be adapted to extreme pressure, total darkness, and chemical energy. At the smallest level, there would be chemosynthetic microbes, similar to the archaea and bacteria that live in Earth hydrothermal vents. These tiny organisms would convert chemicals from the vents into energy, forming the base of the entire food web. Above them, there could be small, soft-bodied creatures that feed on the microbes, creatures with translucent bodies, no eyes, and sensory organs that detect chemicals or movement in the water. Some scientists have even proposed more complex life forms, like small crustacean-like animals, or even soft, intelligent creatures, similar to octopuses, with highly developed nervous systems adapted to the dark ocean environment. These creatures would not need bones, because the water pressure is so high, and they would use bioluminescence to communicate, find food, or attract mates, just like many deep-sea creatures on Earth. The ocean's constant flow and chemical gradients would create diverse habitats, from the hot mineral-rich vents to the cold open ocean, supporting a wide range of life forms. We cannot talk about Europa without talking about the mission that will finally answer our biggest questions, NASA's Europa Clipper. Launched in October 2024, this state-of-the-art spacecraft is traveling 1.8 billion miles to reach Jupiter in 2030, where it will perform 49 close flybys of Europa, getting as close as 16 miles above its surface. Equipped with 9 science instruments, including ice-penetrating radar, spectrometers, magnetometers, and thermal imagers, Europa Clipper will map the ice shell, measure the ocean's depth and salinity, detect organic molecules, and study the moon's geology to determine if it has habitable conditions. This mission is not designed to find life directly, but it will tell us if Europa has all the conditions life needs, paving the way for future missions that might land on the ice drill through and send a submersible into the ocean to search for life directly. What makes Europa so special is that it challenges everything we once thought about, where life can exist. For a long time, scientists thought life could only exist in the habitable zone around a star, where temperatures are just right for liquid water. But Europa proves that liquid water and life can exist far beyond that zone, powered by planetary and tidal forces instead of starlight. This changes the entire game for astrobiology. If life exists on Europa, then it could exist on dozens of other icy moons in our solar system, like Enceladus at Saturn, and on countless icy exoplanets across the galaxy. It would mean life is not a rare accident on Earth, but a common widespread phenomenon in the universe. Exploring Europa is more than just a scientific mission. It is a journey of human curiosity, a quest to understand our place in the cosmos. For thousands of years, we have looked up at the night sky and wondered if we are alone, and Europa might be the place where we find the answer. It is a frozen moon with a warm living ocean, a world of darkness that could be brimming with life, a reminder that the universe is far more amazing, mysterious, and full of possibility than we can ever imagine. Every time we send a spacecraft to explore these distant worlds, we push the boundaries of human knowledge, and Europa is the next great frontier in our search for life beyond Earth. As we wait for Europa Clipper to send back its first data, we can only imagine what wonders lie beneath that icy shell. Maybe there are tiny microbes floating in the dark water, maybe there are strange glowing creatures swimming near the hydrothermal vents, or maybe the ocean is full of life forms we cannot even dream of. Whatever we find, it will change our view of the universe forever. Europa is not just a moon, it is a beacon of hope, a sign that we are never truly alone in this vast, incredible cosmos. Please like, comment, share, and subscribe to the channel.